Hi, sir. Good evening.
Good evening, guys.
Hi, sir. Good evening.
Yeah. Magmat, is that problem solved for you?
Sir, I'm checking now.
Okay. Actually, I checked with the multiple forums in STM webpage. They all said like if you update it to 1.19 version, the problem will get rectified. So that's what they're given as a solution.
I think
But
it is
yours is
updated already.
still 1.19, right?
Yes.
You already
There is
updated
showing,
it.
but in my desktop icon it is showing 1.18.
Which one?
Like in icon where desktop icon is there, no?
That is fine. That is fine. Inside, if you go to about session, you are getting 1.19, right?
Yes, yes.
Okay.
Sir, can you allow the permission for us to download a transcript recordings?
Okay, but I
There
don't
is
know
no
how
option
to.
to download.
I don't know how to download that. I mean, how to give the permission for that. Is there any permission? Is it asking for downloading it?
Sir, that website's asking for allow permission through your
Okay, if there is any
put.
request, just give me the request. I will accept it. Is there anything like a
Yes.
request access?
Yes, sir.
Okay. Then
I
just
will
give that.
check
I will.
and let you know.
Okay, okay. Yeah, okay. So we'll start the class. Just a minute. Okay. So last class we discussed about the queue, right? Okay, how to insert a data, how to create a queue, how to insert a data in a in a queue, and how to get a data from that queue in different task. Okay, all these things we saw yesterday. How to create a queue with different size and different item size and all these things, right? So today we are going to start the synchronization in FreeRTOS. Okay. So as like the last class, at the end, I have explained about the importance of synchronization in the FreeRTOS, right? So synchronization, not only in the FreeRTOS, the synchronization is very much helpful uh, for what to say, whenever you are doing a multiple task at a time. Okay. And whenever there is any multi-threading or a pre-thread happens, there we will be using this synchronization. Okay, so that is the thing. Okay, just a minute. I'll create one more thing. I'll just call it as an okay. So why we need a synchronization in a parallel processing? Okay, so that is a question. So we know what is synchronization. Synchronization means something has to happen within that given time period of a time, like in an order. Okay, so if there is a three task or a three different things happen at a time. Okay, the first thing has to happen in this given set of period. Once it completes, then the second thing. Once it completes, then third thing. Okay, so there will be some synchronization between something which is happening. Okay. So why we need a synchronization in the free RTOS or as I already explained in any multi-threading concept, why we require a synchronization. Okay. So yesterday I gave you one example, right? Like we will be having three different tasks and all these things. Okay. So today we'll see one more thing. Let's assume I'm having an what example I will give. Okay, let's say I'm having this temperature measurement. Okay. Let's assume this is an high priority temperature measurement and control device. Okay. So let's assume it is something like and very something like a nuclear power plant, something like that. Okay. It isn't very high priority. The temperature level should not go even 0.5 degrees Celsius greater than the threshold level. Okay, and similarly, it should not go less than something like in 0.5 degrees Celsius, less than the threshold level. Okay, something like that. That much important. Let's assume like that. Okay, I'm having let's say okay, two different tasks. Task number one and task number two. Okay, task number one is going to measure the temperature. Okay, I'm having a temperature sensor and I wrote a code inside this task number one. It is going to measure the temperature and it will send the temperature to this task number two. Okay, task number two is going to control. Okay, so this is measurement and control, right? So this is something like a control. Let's assume like that. So based on this measured temperature, if it is greater than threshold, okay, I'm going to turn on the cooler. Okay, and if it is less than the threshold minimum, this is threshold maximum. Okay, then I'm just going to turn on the heater. Okay, this is what my concept. Okay, so this operation is going to be done based on the measured temperature. Okay, so this is the input to that device, right? So here I'll be having some different codes. for getting this ADC value and just going to convert this ADC value, analog value into digital value. Okay, and then I'm going to transfer that value to this task number 2. Okay, so this operation I'm going to perform inside task number 1. Let's assume like that. Now what is happening? I'm setting the threshold limit of something like an 30 degrees Celsius as the max. Okay, and 20 degrees Celsius as the minimum. It should not go less than 19.5. Okay, this is my cutoff, and it should not go greater than 30.5. Okay, this is my cutoff. Let's assume like this. Okay, if it crosses 30.5 or if it goes less than 19.5, my system will get failure. Okay, so I have to be very, very precise in measuring this temperature. Okay, now what will happen? It is getting the data, it is transmitting the data, right? Okay, let's assume both are having a same priority, something like a priority number 4 for both the things. Okay, now we already know what is meant by preemption, what will happen if it has a same priority and all these things, right? If it has having a same priority, even before completely execution of this program, in between it will just move to the next task. Okay, that we already saw in an example with this preemption method on. Okay, let's assume I'm just getting the data from the sensor, and while doing this conversion process, I'm getting preempted. Okay, so here there is some garbage value that is going to this task number 2 as a temperature. Okay, now this garbage value will be assumed as my threshold limit, and either the cooler or the heater will turn on. Okay, for the garbage value, it is not even a real value, right? So during this time, what will happen? This process will get completed and it will just have the result, right? Okay, now again, after turning on the cooler or a heater, I'm just again coming back to this task number 1. Okay, now at the time what will happen? This temperature data will be lost because I'm not going to send it, right? Because I already moved to the task number 2. Okay, now again it will come back to this heater number 1, and this ADC value, next ADC value will get. Okay, and that process will keep on running. It will just miss that data occasionally. Okay, in a system where it has to be work precisely for 0.5 seconds, this is very, very a catastrophic kind of thing. Okay, I'm just losing lots of data while transferring from one task to another task during the preemption. Okay, so there is no synchronization between these two tasks. Like, what is the synchronization I'm expecting is, first this task number 1 has to completely get this data. Okay, and then it has to move to this task number 2. Okay, even before it moves to task number 2 also, it should not perform any of this operation without getting this data. Okay, so that is what the synchronization I expect. Even it is preempted, it should not perform any of this operation. It should again come back and wait for this data to be completed. Once it is completed, again it will go there and it will perform this operation. Okay, so that's what I'm expecting asynchronization for this minimum 2 tasks. Okay, so imagine if you're having a huge plant, this plant is having something like some 10 or 20 different temperature measurement sensors like that. Each and every sensor measurement devices is having a 2 different tasks. So there is a 20 different tasks with 20 different priorities. There has to be some synchronization occurs. Okay, so that is very difficult to make it something like an HAL delay or something like an, sorry, not should you use an HAL delay. You should not use something like an VTAS delay. You can use VTAS delay, but the calculation is very difficult. Okay, we don't know when this data will be converted. So we just need to calculate each and every line's execution time period. Okay, we just need to put that time period over here, and we don't know how much data or how much time it takes to turn on the cooler or a heater. Okay, that much task delay we have to give over here. Okay, that is very difficult process. Okay, now instead of that, RTOS is offering some synchronization APIs. Okay, so there are some synchronization methods or synchronization APIs available. Okay, those are, we have something called as a semaphore. Okay, we need, and we'll be having something called as a mutex. Okay, so these two methods are useful for a synchronization between the multiple tasks. Okay, we are going to create a synchronization between multiple tasks by using the semaphore or a mutex. Okay, so in today's class, we will see what is a semaphore, and in tomorrow's class, we will see what is a mutex. Okay, so first semaphore, we will take this one. Okay, semaphore, as like already said, it is an synchronization method. Okay, it is using something called as an key or token method. Okay, so we will be having a key or a token method. The task which has to be executed has to take a key. It has to execute. After completion of this execution, it has to return the key back. Okay, and then next task will take that key and it will execute it. After execution, it will return it back. Okay, so that there will be some sort of synchronization. Okay, so the best example for this is, let's assume we are having a room. Okay, a single room. Let's assume it is a meeting room. Okay, imagine this is a door for this meeting room kind of thing. Okay, now, so we have scheduled a meeting or we have started a meeting at 10 a.m. for one batch. Okay, and we are saying roughly we will finish it around something like an 11:30 a.m. Okay, it may be something like an plus or minus 10 minutes will be there. The next meeting has to start somewhere around 11:15 a.m. Okay, so since they said it will finish something like in 10 minutes, 15 minutes before or 15 minutes after. Okay, we have just scheduled it as an 11:15 a.m. Now what will happen when this meeting is executing or when this meeting is present? Okay, which is happening inside this room. The person who are going to start this meeting, they will come, they will check whether this meeting is currently in. Okay, it is still happening. We'll go back. Again, we will come over here. We will check the meeting is happening. If it is, then we will go there. Okay, again, we will come. If the meeting ends, we will call the person who are going to attend this meeting and they will be going inside this. Okay, so that is and wastage of resource and wastage of time, right? Each and every time a person over here has to come and check whether this meeting has been ended or not. Okay, so similarly, just convert this into our task. We have a task one and task two, and we don't know when this task one will complete for this task two to be executed. Okay, so this task two will go, it will check, okay, the data is not finished. It will again come back. It will again go, it will check, okay, data is not still processed. It will again come back. Okay, it will again go, okay, now this data is finished. I need to take this data and process. Okay, it is actually an resource wastage. Okay, this much amount of memory, this much amount of CPU has been wasted, right? Instead of that, imagine I'm having a key over here. Okay, so whoever has to open this door has to take a key, and there will be a single key. Okay, there will be a single key. Whoever has to open this room, this conference room or a meeting room, they have to take this key, they have to open it. Okay, and they have to use it. Once they finished it, they have to return the key back to this common place. Okay, so whoever is started conducting this meeting at 11:15 a.m., instead of checking this room each and every time, they can check this key. If the key is available, they will take the room, because if the key is available, that means the room is free, right? Okay, they will take this key, they will access this room, and once they finish, they will return it back. Okay, So instead of going inside this room and checking whether the meeting is finished or not, they are just going to take this key, or they're just going to check this key. If the key is available, the meeting can start, or the meeting can wait. Okay. So that is a kind of synchronization the semaphore is going to give in this free RTOS. Okay. So we'll be having a token or a key method. For example, if the task one has to execute something, it has to take the key. Okay. So take the key, then this process will execute and then return the key back. Okay. Again, task number 2, it has to take the key. It will process and it will return the key back. Okay. So that is like there will be some synchronization, right? Once this process has been completed, then only we are returning the key. Okay. During this process, if it is preempted to task number 2, it will check or it will ask to take the key. Okay. But the key is available with the task number 1, right? So we can't able to execute this process. Okay. So it will again go back to task number 1 to finish this process. Once this process has been completely finished, then only we will be returning this key. Okay. Then this task number 2 can take it, it can process and it can return it. Okay. So this is what and synchronization method. Okay. That's a semaphore. Is it clear? Any doubts in this? If there is any doubt, just let me know. Anyone? Venkat, Mohammed Arvind.
Clear, sir.
Okay. Okay. Now, based on this key or a token method, your semaphore has been classified into 2 methods. Okay. One is binary semaphore. Okay. And the next one is we'll be having an counting semaphore. Okay. So this semaphore, that is a key or a token method, that is going to be classified into binary semaphore and counting semaphore. Binary semaphore means we will be having only one key. Okay. The example which I said as this room example, right? We are having only one key for accessing this room. Whoever has to access this room has to take this key, and when they finish, they have to return it back. Okay. Then only the next person can able to take this key. They will execute and they will return it back. Okay. So there will be only one key, and each and every task has to take that particular key and it has to process, it has to return it back. Okay. That is what a binary semaphore is. Whereas counting semaphore, we will be having a multiple keys. Okay. We can able to generate some n number of keys for accessing something. Okay. And we can take multiple keys or we can able to access that much amount of time. Okay. So the example for this counting semaphore is, okay, for binary semaphore, we have this door example, right? Okay. For counting semaphore, let's assume, okay, in office, whenever you are entering any room, you will have an access card, right? So that access card is not an unique one. It is an unique one, but it is not only one access card will be available for the entire employees in the office, right? There will be some n number of access cards will be available. So whoever wants to access that particular room, they can just swipe that card and they can enter it. Okay, that is the example for counting semaphore. Here we can able to create multiple keys. For example, if there is a 10 access card, so 10 people can able to enter into that room. Okay. If the 11th person comes, they have to wait until that one of the 10% has to come out and they have to give the key to the 11th person or the access card to the 11th person. All right. That is what called as a counting semaphore. Counting semaphore will have multiple keys to execute that task. Okay, so that is the semaphore. Clear with this? Any doubts? Anyone wants me to explain it
Clear.
again? I'll explain. Okay. Okay. So in order to use the semaphore, where it is, yeah, here we have semaphore. Okay. So here there are multiple APIs available. Okay, for creating the semaphore and for taking the key and giving the key. Okay, so there are multiple APIs available. As like same thing, we are going to use three different APIs for the semaphore. Okay, one is for creating the semaphore. Okay, for creating also we'll be using two things. One is for creating binary, for creating the counting. Okay, and for taking and giving. So there will be four different APIs we are going to use here. Okay, so this API is for creating the binary semaphore, and this API is for creating the counting semaphore, and this API is for taking the key, and this one is for giving the key. Okay, so there are four different APIs we are going to use in this semaphore uh, topic. Okay, now first one is creating the binary semaphore. Okay, so the API we are going to use is an X semaphore create binary. Okay, I'll just write it over here. For binary semaphore, the API is I'll write it with white. Okay, X semaphore create binary. Okay, now inside this there is nothing. We'll just have a void. Okay, we are not going to use any arguments or any parameters inside this because binary semaphore is having only one key, right? Okay, so there is no need to mention anything inside this. Just create a binary semaphore. That means one key will be automatically created. Okay, now if you want to create the semaphore as a counting mode, okay, or a counting semaphore, then you need to use X semaphore. There is no space here. X semaphore create counting. Now this create counting will ask two parameters. First one is what is the maximum count and what is the initial count. Okay, so this is max count and this is initial count. Okay, the max count is what is the maximum key you need to create and how many key you want to make it available. For example, I'm creating 10 keys, but I want to make only 5 keys available. I just want to keep another 5 keys as a reserve. Okay, then you can give something like a 10 for the maximum count. Okay, and the initial count is you can start from 5. Okay, so you'll be getting something like a 6, 7, 8, 9, 10, or you'll start with 6. So you'll get 6, 7, 8, 9, 10. Okay, so that you can able to do with this initial count. Okay, this is a maximum count. This is an initial count. And if you want to make all 10 keys available, just simply put the initial count as 0. Okay, so that you will get all 10 keys are available. Okay, so that is what create counting is. Right? Okay. The next two APIs are for key. Okay, this is for creating the semaphore. The next two is for creating the key or taking and returning the key back. Okay, so the next one is X semaphore take. Okay, and the next one is X semaphore give. Okay, again this X semaphore take and give will sorry, X semaphore take will get two parameters. Okay, How we will create this binary semaphore means we will create it with the same thing as like how we did for timer and queue. We'll be creating it with something like an handle. Okay, like semaphore handle. Okay, something like this. Let's assume SEMPHR underscore H. Okay, let's assume this is my handle. By using this handle, I'm creating this one. Okay, now this X semaphore take will ask two parameters, right? One is which semaphore I need to take the key. Okay, so you have to give that handle name, and the second one is how long I need to hold this key. Okay, here you can give the time period. For example, if you give something like 1,000 ticks, what will happen? It will take this key and it will hold it for 1,000 ticks. After 1,000 ticks, the key will be automatically given back. Okay, even you are not using this XML for give key. Okay, after this time period, it will automatically give the key back. That is what this time period is for. Okay, this is automatically return the key. Okay, if you want to manually return the key, that means you need to hold it for the maximum time period, right? So you need to give something like an port max delay. Okay, so it will hold the key for the maximum delay time until you are giving it manually. Okay, so that is what the delay time period is. Okay, and similarly the next one is X semaphore give. X semaphore give will ask only one parameter, like which key I need to return back. Okay, so just give that handle name. That's it. Okay, so that is what the X semaphore give. It will ask only one parameter, which semaphore handle or which key I need to return it back. That's it. Okay, so we are going to use these four APIs in our program. For creating the binary, we'll be using this one, and this one. For creating the counting, we'll be using this, and this. Okay, so that is for the semaphore. Okay, we will see the examples like how to create an semaphore, how to take the key, give the key. What happens if you are not using any key? Okay, all these things we will see now. Okay, is it clear? Shall we go for the code? If there is any doubts in this or anything you want to know, just let me know. I'll explain it again, or we will go to the project. Is it clear?
Yes, sir.
Okay. Okay. So now I'm just going to create a new project. So one more thing for Mohammed. So Mohammed, you are not getting this IOC file, right? Okay.
Yes, sir.
Now instead of creating file new STM32 project, okay, you can actually configure an existing IOC file to a new project. Okay.
Okay.
So
Okay.
you can give this. I will explain. Okay, this is for only Mohammed. Okay. So file new, go to this existing configuration file. Okay, click that. Let it download. Mhm. Okay, it will create a existing project folder, something like that. Okay, you just need to
Okay.
browse the IOC file. Just click browse. For example, if my IOC file is already available in any of this file, which is you have previously created. Okay, for example, I'm just going to this check. There is an IOC file, check.ioc. Okay, just select that IOC file and click open, and it will just select everything. Okay, there is no need to change anything. Only change the project name. Okay, so project
Okay.
name, I'm just giving something like a check one, and then click finish, and the IOC file will be loaded. for the configuration which you done to the previous one. Okay, you can change the configuration if you want inside this IOC. That's it. Okay, so instead of creating a new one, you can do this.
It is showing configuration file location is invalid.
Okay, but for me
Later
it
I'll
is
show.
opening. See, it's opening for me. Okay. Can you just quickly share the screen?
Yes, sir.
Yeah. Okay. Yeah. Okay. Do the same thing. Okay.
Yes,
Click browse. Just leave that one. Okay. Select this IOC file. This cooperative task. That IOC file. Open. Okay. Now just change the project name. Something like semaphore. Okay. Give finish. Okay. It will create. What is that IOC file? But for me, it is showing this IOC file. But why it is not for you?
something properties or configuration cannot change.
Include SRC build. Oh, no, that is for build configurations. Okay, can you just go to this? This is same one. You just close this one. Go to this project on top. No, top. There's a project, right? Click that. Go to properties. Okay. Can you just click that restore defaults? Okay. Apply and close. Okay. Now go to file.
Same this one.
No, go to the normal one, STM32 project. Yeah. Select the board. So others, you can create your project, okay? And do all the steps. No, it is still showing the empty on the bottom. Okay, just click cancel. Right click the semaphore project. New. Go to other. And be able to create a IOC file over there. Just click launch targets. Open that. No, open ST. No, not that open ST. We just need an IOC file. Okay. Click open general. What's there? It is a file folder project untitled file. Okay, click cancel. We will try one more method. Go to that folder which you have already stored the files. Okay, copy this. No, go to the project. Open any project. Copy that IOC file. No, not that one. Yeah, copy. Open this. Right click. Paste. Okay, can you just double click that? Okay, it's invalid, must be active IOC file. Okay, right click that IOC file. Go to properties. Just a minute. I'm just opening this IOC file, properties. Okay, now inside this check folder, C++ build, variables, environment, JSON logging settings. Okay. Okay, there is no such thing. Okay, click cancel. Is there any other method? Okay. Right click this semaphore. Click close project. Okay, now file. Open project from file system. Click directory. Just go back. Again, go back. Okay, where is that folder? Free RTOS project. Okay, open any folder. No, not select folder. Okay, just click finish. Cancel, click finish. Okay, can you just open the task, cooperative task? Double click. Okay, now we have, right? Go to file. Um, okay, here we can't do anything, right? Okay, now you can go to this folder, not this one, the folder where you are stored. Cooperative task, right?
Yes.
Okay, just go back once. Okay, copy that cooperative task and create a copy.
Then where to paste?
Just paste it here. Same place, same place. Okay, now go to this STM. Right click your cooperative task. Is there any rename? Yeah, rename is there, right? Go to rename and change it to semaphore. Which is already existed. Just give underscore new. Click OK. Okay. Now double click and open that. Okay, everything will be changed to semaphore new only. You can use it something like this.
Okay.
Yeah. Okay. Okay, sorry guys. Yeah, I'll just close this project. Close project. I'll just close project this also. Okay, I'll create a new STM32 project. I'm going to select the F334. Here I'm just going to give semaphore. Finish. Okay, I'm not going to change anything as of now inside this IOC. I'm just directly go to this one. Free RTOS kernel, right click, copy, and I'll paste it in the semaphore. Okay, right click this, properties. I'm going to exclude. Right click semaphore, properties, include path. I'm just going to add everything inside this folder. Mem management, this one and this one. Apply and close. Rebuild. And inside the system core, I'm just going for this RCC. This is bypass, and this is my crystal ceramic. In sys, I'm going for this timer 3, and in NVIC, I'm going to remove the system tick timer, pendable request, and system service. So Control S, generate the code. Okay, now for this printf statement, I'm just opening this ITM core and I'll paste it inside this core src syscall. I'll paste it here. ITM SendCare. This I'm going to paste. Save, build. Okay. So I hope there is no errors. Yeah, I'm going to close this. Okay, now we are going to write the code. Okay, now in order to use this semaphore, any of the semaphore APIs, we need to include an header file called as semphr.h. That is semaphore short form. Okay, semphr.h. The semaphore.h header file we need to add in our project. Okay, so I'm just going here. Now inside this includes hash include. First one is my free RTOS. Okay, and after that I'll have an task.h. After that I'll have my semphr sem4.h, and I'll have my hash include stdio.h. Okay, so I've added these four header files. Okay, and in private variable, as like our queue and timer, I'm just going to create an handle for this for a semaphore. Okay, so it is semaphore handle underscore t. Okay, I'm just going to give something like an binary underscore semaphore. You can give any name. I'm just giving the handle name as binary semaphore. Okay, so I'm going to create a semaphore by using this name only. So initially what I'm doing, I'm just going for this where user code begin to. Okay, here I'm just going to create the semaphore first. Okay, so what is the API? API is handle. Sorry, my handle is binary semaphore. Okay, this is my handle, which is equal to. So the API for creating the semaphore is x semaphore create binary. Okay, so x semaphore create binary. Okay, so there is no arguments or parameters inside this. Since it has a void, you can just leave it as it is. Just a minute. Okay. After creating this binary semaphore, as like how we are creating the task. Okay, so we are going to create two different tasks. So one task is going to take the key, do the process and return the key. Other task has to take the key, execute and return back. Okay, so that we are going to do right now. Okay, so I'm just going to give x task create. Okay, so it'll ask again the same 6 parameters. So what I'm going to do is I'm just going to give something like an task number 1 here. Okay, with the T caps. So this is inside double quotes, task 1, and depth is 200. This is null. And I'm just giving a same priority for both the things. I'm just giving something like a 2 as a priority. And similarly for the other task also, I'm just giving it as a task 2. Sorry, it has task number 2, and this is task number 2, and everything else is same. Okay. So same priority I have given for both this task 1 and task 2. After that, I'm going to start the scheduler. V task start scheduler. Okay. Now, here we need to do one more thing. As like, imagine this is the room, right? Okay. When this first person comes, during that time, the key has to be available, right? Okay. Not this first person is taking the key with them. So the key is already available outside. He has to take the key and open this, and the second person will check the key. If the key is available, they will open it. Okay. So initially this key has to be available because we have only one key. someone has to take the key and use it, right? So initially the key has to be available for any task to take. Okay, so for that we need to give the key first. So what is the API for giving the key? That is X semaphore give. Okay, so we just need to give X semaphore. Okay, give. It will ask one parameter, which key I need to return back. Okay, so this key I need to return. So I'm just giving the binary semaphore handle name. Okay, so initially the key available. So making the key available initially. Okay, so I'm just giving this key for making this key initially available for everyone. Okay, now I need to write what I need to do for this task 1 and task 2. First, I will do this without task 1 and task 2. I mean, without this semaphore take and give key. Okay, after that, we will see what changes it will do for the semaphore handle. Okay, so I'm just giving void pointer. Inside this, I'll just put an while of 1. Okay, here I'm just putting a printf statement. Inside this, I'll just simply print inside task 1. 2, 3, 4, 5. Okay, this is for like just for my understanding I'm giving. There is no need to give this star and all these things. Okay. Okay. You can simply put inside task 1 or this is task 1, something like that. There is no issues with that. Okay. So this is for task number 1. Okay. And similarly, I'm just going to create for task number 2. Okay. First, we will see what will happen without any key involvement. So this is task number 2. Okay, now for task number 2, instead of star, I'm just giving something like let's say 1, 2, 3, 4, 5, 5 dashes, and here also I'm just giving 5 dashes. 1, 2, 3, 4. Okay, so now I need to declare this function on the private function prototype, which is on the top where it is. Yeah, here. Okay, so this is my task number 1 and this is my task number 2. So that's it. Now I'm just building the code. Okay, there is 0 errors and warning. I'm going to connect my board now to the PC. Just a minute. Okay, board is connected. Now I'm just going to right click, debug STM32. Enabling serial wire viewer and then click OK. So this is switch. And in HCM data console, I'm just going to configure it for port number 0 and this is for trace. Okay, now if I click resume, you can see this is not even in the order. Okay, there is no synchronization between the task execution. So I'll just copy this and paste it in the new notepad. You can see there is no synchronization between this one. Okay, first two were right. Okay, it is properly printing. After that, it stops suddenly and there is something happening. This is not even a synchronized task. Okay, so now what I'm doing, I'm just going to create a semaphore over here. That is, I'm going to create a key and what will happen, we will see. Okay, now inside this while of 1, initially before execution, I need to take the key. Okay, let's say X semaphore take. Okay, it will ask which semaphore key I need to take. That is my binary semaphore. Okay. And how much time I need to take it? I need to manually return it back. So for the port max delay time, okay, I'm just holding the key. So I'm taking the key, I'm executing this. After that, I'm just returning the key back. So it is X semaphore give, I will give. Okay, it will ask again the which semaphore, the same binary semaphore key which I have taken there. I'm just returning it back. Okay, so after this, I'll just give a very little delay. Okay, for this to move to the next task, something like that. Okay. I'll just copy the same thing. Here also, I just need to make this take, and here I'm just going to give it back. Okay. So this is taking, executing, returning. Okay. Again, taking, executing, and returning. Now you can see the difference between the previous output and this output. Okay, you can see over here now. If I click resume, I'll pass this. Now I'm just copying this and I will create a new notepad. Now you can see the difference in output. Okay, it is inside task 2, task number 1, task number 2, task number 1. Okay, again this task number 1 and task number 2, task number 1, task number 1, task number 2. Okay, so it is in an order, or there is some synchronization that is happening between these two tasks. Okay, we are creating a synchronized task by using this key. Okay, or this semaphore method. Okay, now in the same thing, let's do one small alteration. Okay, now inside this task number 1, I am taking the key, but I am not returning it back. Okay, here I'm taking the key, execution and returning. Here I'm just taking the key, but I'm not returning it back. Okay, now we can see what will happen to the output. Can anyone guess what will be the output? I'm taking the key. Okay, I'm executing it and returning it back in task number 2. Okay, in task number 1, I'm taking the key, I'm executing it, but I'm not returning it back. Okay, now what will happen? Any idea?
So task number 2, later it won't exist. It won't come.
Task number 2.
Yeah, like first it will it will print inside task 2.
Okay,
Then it will go to task 1.
okay.
From here it will keep printing inside task 1.
It will keep printing the same inside task 1.
Yes.
Okay. Now I'm just going to resume it. Okay. This is what my output. Only 2 line. Okay. First one, what happened is it is going inside the task number 2. Okay. It's executed. Yeah, that is, it is taking the key. Okay. And it is executing and it needs the key back. Okay. Now here we are going. It is taking the key. It is printing, but it is not returning the key back. Still the key is available with the task number 1. Now we are going to this task number 2 in the next cycle. Now your task number 2 is trying to take the key, but the key is not available. Still your task number 1 holds the key, right? So this will not execute. Okay. Again, if you go back to task number 1, it will still trying to take the key, which is not even available. Okay. So it will execute only once this one and this one, and it will stuck over here. Okay. So without key, none of this task will get executed for the second time. Okay. So that is what the importance of key. Without this key, your task will not even execute. Okay, clear?
Yes, sir.
Yeah. Okay, so this is an binary semaphore. Okay, yeah. So copy the code. So this is for the header file. Okay, just let me know once you finished it. I will just scroll down.
Sir, you can scroll down, sir.
Create an handle.
Done, sir. Done, sir. Sir, scroll down. Sir, done.
Okay. Are you getting output?
Sir, I'm building now.
Okay.
Yes, I'm getting out.
Okay. So others, you got your output. Okay, so next we will see the counting semaphore. Okay, so I'm just going to create a new project, and Mohammed, you can just do the same thing. You can copy and paste and do the same kind of thing.
Okay.
Yeah. Okay, so this is next. I'm just going to give the counting semaphore. Okay, so this semaphore, I'm just going to close it. Right, so I'm just going to copy this FreeRTOS kernel. I'll paste it here. Right click, properties, exclude, same thing again, workspace. So here I'm just going to RCC bypass crystal ceramic timer 3 and code generation system tick pendable system service. Okay, this is done. Now the ITM SendCare inside this src syscall.c, paste ITM SendCare. Paste. Build. Okay, so zero errors and warning. I'm just going to start writing the code. Okay, so initially that is my hash include files. Okay, so first one is my freeRTOS.h, and second one is my task.h, and third one for using the semaphore, I'm just going to give a cmphr.h, and the next one is my hash include stdio.h. Okay, so 4 different data files I've already added, and in private variable I'm just going to declare a semaphore handle. Okay, so I'm just going to give semaphore handle underscore t. Here I'm just going to give something like an count semaphore. Okay, so I'll just copy this one. Okay, so this is, I have created one handle and named it as an counting semaphore, and inside this user code begin to, I'm just going to create a semaphore now. Okay, so this is my user code begin to. So now inside this, let's say this counting semaphore, which is equal to x semaphore create counting. Okay, so open this, and it will ask two parameters. One is what is the maximum count of the semaphore and what is the initial count. Okay, so maximum count, I'm just giving something like a 5 key, and initial count, I'm just making it as a 0. Okay, so that means I'm going to create 5 different keys for the semaphore, and I'm just going to make all 5 keys are available. Right. After that, X task create. First one, I'm just giving something like a task 1. this hyphen and all. Okay, this is task 1. Here it is task -1, and depth is, I'll give 200, and parameter is null, and the priority I'll give something like 3, and task null. Okay, so here I'm just copying this. I'll paste. This is for task number 2. Okay, here I'm just going to make both the task as a different priority, because initially I want to make the key available, and this task is going to take the key and it is going to process it. Okay, as like how I have given the example of the access card. Okay, here this access card will be available and it will take the access card and execute. Yes, so that is what this one is. Okay, now after creating the task, I'm just going to start the scheduler. The task start scheduler. Okay, here I'm not going to make this key available because anyhow I'll be having a multiple keys, so I can able to use that anywhere in my task. Okay, previously what happens, I have only one key. Okay, so in order to use that key, I need to make it available at the top. Okay, here I have multiple keys, so there is no need to put all these keys available over here. Okay, so I'm just directly going to this task number 1. In this user code begin 4. Okay, so here I'm just going to give void task. Is it T capital? Yeah, T capital 1. So this is task 1. Okay, inside this I'm just going to give void pointer. Okay, so here this is while of 1. Inside while of 1, what should we do? Okay, first we will try without this semaphore. Okay, we will see what is happening. I'll give something like v task delay of something like 2000 ticks. Okay, after 2000 ticks, I'm just going to put a printf statement, that is I'll just put some star delay expired. Okay, so I'll put 1 2 3 4 5 6 7 8 9. So this is /r/n. Okay, so I'll just simply give a VTAS delay for some 2000 ticks, and I'll just give this as a delay expired. Okay, now what will happen, since this task 1 has an high priority, it will directly come here, and I'm selling, or I'm telling my scheduler that I need some 2000 ticks delay period. Okay, now what will happen during this 2000 ticks, my task number 2 will get executed, right? Okay, that is what we saw in our previous examples. Okay, so I'm just going to give task 2 with void pointer. Okay, now inside this while pointer, I'm just going to create a while of 1, not while of 1. Okay, now inside this while of 1, I'm just going to print something like an printf. Okay, I'll put 1 2 3 4, sorry. This is task number 2. This is /r/n. Okay, I'm not going to do anything over here. Only is I'm just creating, this is task 2 that has to be printed. Okay, now during this 2000 ticks, this task will be printing. After 2000 ticks, I'm just going to print a delay expired, and again I'm just going to print a 2000 ticks, the same thing. Okay, so that's what I'm trying to do. Let's see here, private function prototype. I'm just building, or I'm just declaring this one. So now building the code. So it has 0 errors and warning. Now I'm going to debug it. So right click, debug as STMC C++ applications. Now inside this, I'm just going for this debugging, and I'll just enable this serial wire viewer. Okay. Now click OK. Switch. Okay, now inside this SVM ITM SWV ITM data console, I'm just going to make this port 0 enabled and trace enabled. Now if I click resume, okay, you can see this task has been running for a huge amount of time. Okay, I'll just create a new one. Is there any star? You can see this is task 2, task 2, task 2, task 2, task 2, task 2. I'll just execute for more time. Okay, since it is 2000 ticks, okay, it is executing for 2000 times. Okay, we can enable. Okay, now you can see the difference, right? What is happening is for this 2000 ticks, even though your task number 1 has an highest priority, okay, what will happen? It will execute only once. After that, since you are given this delay, it will directly go and it will execute the this is task number 2. Okay, now I don't want this to be executed for an infinite amount of time. Okay, instead I want it to be executed for a specific time period. Okay, so for that what I'm going to do is I'm just going to give some key, or I'm just giving some access card for this people to be entered. Okay, so for that I'll just give something like an X semaphore give. Okay, inside it is asking what semaphore. I'm just giving count semaphore. Okay, now I'm just going to make this available for 3 times. I have 5 keys, right? But here I am just making it available for 3 times. Now inside this, what will happen? I'm just going to take this key. So X semaphore take. Okay, inside this, I'm just going to give the same X semaphore count for port max delay. Okay. Now you can see the difference in output. Instead of printing this, this is task 2 for an infinite amount of time. It's not an infinite, but it's for an huge amount of time. It will only execute for the amount of key that is available. Okay, so how many keys we are available here? We have given only 3 keys, right? Okay, so it will take or it will execute only 3 times. Okay, that is what going to be happen. So if I just click resume, you can see this is task 2 will be printed for 3 times and then delay expired, then again 3 times delay expired, again 3 times delay expired. Okay, this will be keep on executing again and again because we have made only 3 key available for our task number 2. Okay, so this is executing for 3 times. After that it will again come back to task number 1 and it will wait for the delay to be expired. After that again 3 keys are available, right? So it will execute for 3 times, then again the delay expired, then again 3 times. Okay, so if you want any specific task to be executed for an some amount of time, okay, so this task has to be executed once, then the other task has to be executed for n number of times, then you can use something like that. Okay, instead of 3, you can see if I give something like an 4 keys are available. Okay, so now what will happen? This will execute for 4 times, as simple as that. Okay, so the amount of times the key is available, that much amount of keys will be taken by the task number 2 and it will start executing it. Okay, so I'll just going to resume it. Now we can see it is executing for 4 times, delay expired, 4 times and delay expired. Okay, I'll just pass this one, copy, and I'll just paste it here. Okay, now we can see it is executing for 4 times then this delay expired, then 4 times, then this delay expired, and all these things. Okay, so this is the difference between binary semaphore and counting semaphore. Binary semaphore will execute only once whenever you want to execute a task, um, simultaneously, like 101010 something like that, then you go for binary semaphore. And if you want to execute any particular task for n number of times, then you can go for a counting semaphore. Okay, clear? Any doubts?
Clear, sir.
Okay, so the code is same until this one. Okay, like what you did for the same binary semaphore, do this for the counting semaphore also, and start from here. Okay, so let me know once you finish. I will just scroll down.
Sir, scroll down. Sir, scroll down. Sir, complete it. I'm getting output.
Okay. So this is the semaphore, okay, binary and some counting. So we can use it according to the applications. If you want any applications to be executed for n number of times, go for a counting semaphore. Or if you want to be executed it simultaneously, then go for an binary semaphore. Okay. So next class we will see the mutex, that is a mutual exclusion. So I think that might be our last class in free RTOS. Yeah. Okay. So we'll see the mutex on Monday. Okay. So tomorrow we don't have a class. We'll see the mutex on Monday. Okay. So mutex is again the same thing as like this synchronization, but is for the uh, shared memory. Okay. Instead of executing the task in a synchronization, we will execute the task based on the uh, shared memory. Okay, so that is for the mutual exclusion. We will see that on Monday. Okay, so by Monday your RTOS project, RTOS module will get complete. So as like we planned yesterday, the next full week will be completely for the project submission. Okay, so we'll plan that on Monday. Okay. So thank you. Bye. We'll see you on Monday.
Thank you, sir. Bye.
Yeah. Thank you. Bye.
Thank you, sir.
Thank you.
Thank
Bye.
you, sir.
Thank you.